Assalamualaikum warahmatullahi wabarakatuh. I'm Raihanah. I'm from Bachelor of Civil Engineering Technology Construction with Honor Year 3 from University Tun Hussein on Malaysia. I'm going to present the influence supplement palm oil fluid edge profile and expanded polystyrene EPS for improving bonding behavior of steel and concrete. And special thanks for my supervisor, IR Technologies Muhammad Hairi bin Osman. Alright, for the presentation online, for influence supplement palm oil full ash buffer and expanded polystyrene EPS for improving bonding behavior of steel and concrete. First, I'm going to highlight the introduction, the project objective, project scope, expected outcome, literature review, methodology, expected result, and the conclusion. Alright, for the introduction, first, concrete and steel are a pretty well structured element. It is not a distinctive construction material because it is a mixture of cement, crushed stone, aggregate, and water. However, adding palm oil full ash profile and expanded polystyrene EPS can increase the compressive strength and durability and lighten the weight of the concrete. Currently, the concrete industry poses a threat to the worldwide ecology. To achieve the greater sustainability in the building construction sector, the researcher in this field must focus on the use of the alternative renewable resources, such as palm oil waste. And adding the expanded polystyrene EPS also has a high load bearing capacity at a low weight, absolute water, and low permeability, air tightness for controlled environment, a long life, high reliability, rapid and cost-effective construction. We have three problem statement here. First is low density. Okay, as we know that a concrete inherited weakness is its propensity to crack, which cannot be avoided. And second is cement produce the most carbon dioxide emission. As we know that the sustainable of the concrete is a significant problem that require attention because the manufacture of cement account for up to 10% of world carbon dioxide emission. And the third is POFA produce waste product. As we know that POFA is a waste product produced by biomass thermal power plant that burn oil palm leftover to create energy. Because palm oil is one of the primary raw material need to make biodiesel, POFA production is expected to rise year after year. So maybe year after year, the production of POFA will rising. So the waste of the product of the POFA will also rise. Alright, for the project objective, they have three objectives in this project. First, to investigate the characteristic of palm oil fluid ash POFA and expanded polystyrene EPS. And second, to study the bonding of steel and concrete that contain 30% of palm oil fluid ash POFA and expanded polystyrene EPS. And the third is to study the failure pattern of EPS POFA concrete subjected to a pull-out test. Okay, for the scope of work, this project scope was limited on using the same type of cement grade, palm oil full ash POFA type, expanded polystyrene EPS type and size, and the same type of aggregate. It also investigate the characteristic of palm oil full ash POFA and expanded polystyrene EPS. By the test will be done for this characteristic is X-ray diffraction analysis to determine the material crystallographic structure. And next, the compression test is used to study the bonding of steel and concrete that contain 30% of palm oil full ash POFA and expanded polystyrene EPS. And also, last is study the failure pattern EPS POFA concrete subjected to a pull-out test. And for the expected outcome, the bonding behavior of steel and concrete containing 30% palm oil full ash POFA and EPS use the same grade of cement, aggregate type and size of POFA and EPS, such the function of the EPS and POFA in adding to concrete mixture can improve the strength and absolute water in the concrete. Furthermore, the standard mixture of the concrete, such as adding cement, sand aggregate, and water, was improving by adding POFA and EPS. By doing the experiment, the expected is that the bonding behavior of steel and concrete can gain compressive strength and durability and lighten the weight of the concrete. Alright, for the literature review, the research have been conducted by replacing 30% of POPA with the weight of Portland Pozzolana cement and EPS volume of 30% by replacing coarse aggregate. However, there is still one of the least studied replacing usage by the percentage of POFA and EPS and study about the combination of POFA and EPS in this concrete. This literature review in this report consists literature review based on first palm oil fuel ash potential, palm oil fuel ash advantage, palm oil fuel ash composition, expanded polystyrene EPS, expanded polystyrene EPS potential, expanded polystyrene EPS advantage, replacing EPS with aggregate, characteristics of involved cementinous barrier. Alright, for the methodology, we have a third test that will be done. First, pull-out test, compression test, and X-ray diffraction analysis, that's known as XRD. For the methodology flowchart, first I identify the problem. Then I find the literature review that's suitable for the problem, and start to prepare the material. So the material that I use in this methodology is ordinary Portland cement, grade 25, fine aggregate and coarse aggregate, POFA and EPS. And then start to prepare the sample. So between the prepared sample, they have two different, which is concrete mixed with 30% POFA and EPS, and the one is concrete mixed with 0% of EPS of POFA and EPF. So we divide into 48 cube and rectangular for the compression cube test and pull out test. And we also have done the STF test, which STF test is for the POFA and expanded polystyrene EPS. Then after we got the data, we will analysis whether is this done successfully or not. If it's not done successfully, we will repeat it again in the sample preparation. And if it's successfully, we will compare the sample with without 30% POFA and or with 30% POFA, and we start to making the conclusion and the end. Okay, for the sample preparation, in this experiment, we'll use 48 sample which have the same cube shape and the same dimension of each concrete block. First, for the compression test, we'll use the cube test. Okay, the cube test is 100 meter cube. And for the pull-out test, we'll use the rectangular size, which is 5 mm, 5 mm times 250 mm times 250 mm. Okay, the sample used Portland cement grade 25 as shown in this picture, and the sample is divided into two, which has mixed with the 30% POFA and combined with the APS, and one mix is 0% of POFA and also have a APF for the 24 cube, and one is the standard concrete mixed with without POFA for 24 cube, which is the concrete mix has been designed for grade 25 concrete based on the DOE. For the methodology sample preparation, the concrete mix was used as the medium for preparing the concrete mix design, and the concrete was tested using the cube test for compression test, and the curing process has been undergo for 7 days and 28 days to get the result. Okay, for as we shown that the total is 24. This is for the compression test. For the methodology sample preparation, have a divide by the test, which is pull-out test and the compression test shown in the table. Okay, for this, shown in the table is the POFA with 30% POFA, and EPS till the 0% till the 30% EPS, and the number uh, of each sample is um, 12, 12 sample, and if you total with the pull out test and compression test will be 24 number of sample. And the sample also have been divided by test, pull out test and compression test, but the difference is the POFA is 0%. And the same is EPS, also 0% till the 30%, and the number sample also the same. For the pull-out test is 12 sample, and compression is also 12 sample. So the total of sample is 24 sample. Okay, for the sample preparation, the tensile strength of each sample of the concrete block will be determined using the universal testing machine UTM. As indicated in this figure, the concrete block has been investigated by observing the concrete block while being tested, and the concrete block will be recorded by the camera for future observation and reference for data analysis while gathering the result for each tensile strength for each block. Okay, we were using the universal testing machine, was the machine was created to perform various tensile and compression tests and experiment. As illustrated below, the machine contains two solid bar and two solid rail bar connecting the high and lower holder. The specimen of sample will be put in the center of the higher and lower holder and attached to the lower holder. The machine will start pulling or pushing the sample until it reaches its maximum sample capacity. The outcome can be interpreted in light of the cement requirement. While the testing was underway, the results were visible at the nearby gauge length as shown in the figure below, and the results obtained from the computer were interpreted using the graph. Then we also using compression testing machine. UTM is because it is a universal testing machine designed to measure the strength and deformation behavior of a material under compression pressure. This machine may be used to describe the material behavior under the compressive load. During this test, compressing pattern or specific instrument installed on a universal testing machine apply pressure to the specimen to determine various characteristics of the material being tested. The test data yield finding in the form of the stress strain diagram, which shows the elastic limit, proportionality limit, yield point, and in a certain situation, compressive strength, among other things. Okay, the method of X-ray diffraction, or we call XRD, is used to examine the atomic or molecular structure of material. It is non-destructive and work well with crystalline or partially crystalline material because the substance being examined is often finely pulverized to a uniform condition. This approach, known as X-ray powder diffraction. For this testing, data was collected after each sample was tested and documented. Results for all sorts of samples were gathered and recorded in order to analyze the data acquired from the test performed. The results of the test were analyzed to see if the objectives were met or not. In conclusion, the research that influenced supplement palm oil full ash POFA and expanded polystyrene EPS for improving bonding behavior of steel and concrete was improvement that should be gained in civil engineering field. The improvement in structure by this research for the concrete can gain the compressive strength, durability, and lighten the weight of concrete. The investigation to find the characteristic of profile and EPS. The study to find the meaning of steel and profile of EPS profile, and the study of failure pattern of EPS profile can determine using SRD test, compression test, and pull-out test. Okay, that's all for me. Thank you. In conclusion, research that influence supplement palm oil voltage profile and expanded blistering EPS for improving